the graphs of sine and cos, okay, up to this point, you now know how to use a calculator, how to do a table of value with the calculator and manually, and you can plot and then sketch. So let's introduce the graph of tan. Then I'll talk about reflection about the x-axis as well. So let's start with the basic graph. Basic graph. Oh, I know why. Okay, now the basic graph of tan, right, we stage it from 0 to 360. So you're going to have something like this.
Same like what we did.
This is basic graph. Y equal to tan x. That's the basic graph. So we have got x there, then y. When x is 0, y is 0. Okay? Now for time, the step for the period is 180, but the step is 45 degrees. So we may need to put the 45 degrees there. Okay? But okay, you may need to put the 45 degrees. You end up having many values of x, of which in my case I don't have the space. So I'll put 90 here. So time 90 is undefined. Then you've got tan 180.
So what's the symbol for?
There's no symbol.
So is it better? What are you going to do on the ground?
What?
What are you going to do on the ground? So this goes to the body.
Don't worry, I'm going to explain that. So, what's tan 180?
Can 1 0. So can I have a 1?
And then 270. You will get undefined.
Yes.
And then for 360, that's another 0. Right now, this is very important for you to know. You remember when you were sketching the graph of a hyperbola when you're doing the algebraic graphs, and you were drawing asymptotes. Now the graph of tan has got asymptotes. Now you get the asymptote where the y value is undefined. Where you've got the y value is undefined, that's where you get your asymptote. Okay? So if I am to sketch it, I will sketch the graph between 0 and 180. You can put 2 there to be 1. The main concern is 1. Then we have 270 and then 360. Right? Tan 45 is 1, so the graph, first thing, we put the asymptote at x equal to 90 because when x is 90, y is undefined. So we have an asymptote. Okay? Also, when x is 270, y is undefined, we have another asymptote.
So wait, I'm trying to draw.
When you are drawing the graph, you draw an asymptote. Okay. Yeah. So from between 0 to 360, you've got 2 asymptotes. Okay? When x is 0, means you are starting from here. Tan 45 is 1, so it will pass through that point. So you will draw it to look like this. Okay? It has to go all the way back. Right? That's the first curve between the y-axis and the asymptote. Okay? And the first asymptote. Then, between the two asymptotes, you're going to have a full curve which starts right at the bottom on the negative side. Okay? So, between 90 and 180, there are some values there. Right? We have got 135 somewhere here, so we have got another graph. It's going to pass through the point where x is 135, then it passes through there, then 225 is the tan 225 is 1. Yeah, like so right, okay. Just to make things easier for you. The period of the graph is 180.
It's different.
The graph of tan is different. The period is not 360, it's 180. Okay? So the step on your calculator is going to be 180 degrees divided by 4, and you get 45 degrees. Right? So my suggestion is, when you are using a calculator, your step is going to be 45 degrees. So you get lots of values of x. Okay? In my case, I said I don't have enough space here for me to write all of it. Because I have to put 45 here, I have to put 135, I have to put 225, I have to put 305. Now, I don't have the space for me to do all that. So use your calculator, because you now know how to use your calculator. Okay? You take out your calculator, put that function y equal to tan x. You start from 0, your end is 360, your step will be 45 degrees. Don't ask me that, because you already know how to do it. Everything we're doing for sine and cos, follow that. The only difference is that the step is now 45. It's not 90 like sine for sine and cos.
So,
are you following?
is there a specific amount of fee that was used?
Yes, it's the step is 45. You divide the period by 4. For sine and cos, we're saying 360 divided by 4, we're getting 90. That's why we're using a step of 90 for sine and cos.
Because tan 45 is equal to 1.
Yes.
Like, so we can put it there.
Yes, that's why I put it here. Because the graph will pass through this point. Tan 135 is here. Tan 225 is here. Tan 305 is going to be 315. So 315 is going to be somewhere there. Yes. So,
But I know it's so.
yes, you've got a calculator. Start 0. Okay, press equal. You are ending at 360. Then you press equal. Do it as I am doing it. Okay? The only way you can understand it is by practice, by doing it as well. Then the step for tan is 45 degrees. Okay? You have to be very careful. If you are given the graph of tan, your step 45. If you forget that in the test, shame on you. Alright, so put 45. Then you press equal. It gives you that. Now, do you see it that when x is 45, y is 1? Forget about the column for g of x. Right? When x is 90, it says error. When x is 135, it's minus 1, which is the point that I have here. This point. I've got it there. Yes, it is. Then you carry on. You carry on. All the values are there. Okay? 270, and then you've got 315 is minus 1. So I've shown you that.
Oh, so those are the points for plus.
Yes.
But how do you remember that?
I've got experience.
No,
No, you know over time. Okay. Can I have your attention? Can I have your attention? Can you stop talking? If you put the equation incorrectly, then calculator will give you a wrong output. Okay, so once you are here, I've checked the first scale. Right? So the 45, x equal to 45 is very important. Then the x equal to 135, you can see it on your calculator. Okay? You are supposed to be seeing those values on your calculator. X equal to 135, y is minus 1. X equal to 180, y is 0. X equal to 225, y is positive 1. X is equal to 270, error or undefined. When x is 315, you get negative 1. So I sketch the first curve. This is half of a full curve. The next one is gonna be like this. And then it goes. Okay?
So you stop at that.
Then the last one passes through 315 and 1, and then it stops. Like that.
So you don't say
No. This curve plus that half, they make one complete curve. Okay? Listen. So this is the basic graph of y equal to tan x. Okay? That's the basic graph. That's how it looks like. Okay? Now, pay attention. Can you pay attention? This graph does not have an amplitude. Okay? I told you it doesn't have an amplitude. Okay? So the period is 180. Then you can write it no amplitude. Or you can say amplitude is undefined. No amplitude. Your range will be from minus infinity to positive infinity.
So say the amplitude is 0, is it wrong?
No. It's wrong. The amplitude can never be 0. But it can be undefined because we don't know what's the maximum and what's the what? Minimum. So you can't say the amplitude is 0. If you say the amplitude is 0, it means the graph doesn't exist, which is not true.
You don't even know how to put x in the
Alright? So make sure you are aware of this. Okay? Alright? Like the next exercise, since you've understood, you can use your calculator. Your exercise now is for you to sketch this graph. Your period is equal to 108 degrees. The period of any tan graph in this grade is 180. Okay? Don't make the confusion between 360 and 180. For tan it's 180, sine and cos 360. No amplitude.
You're saying you get it wrong, but you still have the period right. Is it still right?
No. Okay. Remember here, in most cases, when the person asks you to sketch, they won't test you for the period. Okay? But because I'm teaching, I'm emphasizing because the concept of period is a very important concept. Amplitude it doesn't exist. The range is going to be y is an element from minus infinity up to positive infinity.
So see, now you got circular graph.
Okay? Or you can write as minus less than 1, yeah. Because why am I putting circular bracket? Because minus infinity and positive infinity are not exact values.
Oh, so when they
Okay? You can write like that. No. There's no maximum. That's why there's no amplitude. There's no specific maximum value or specific minimum value. Okay? Are you following? Now, do you remember me when I taught increasing and decreasing functions?
No.
Listen, when I taught you algebraic functions, I told you what an increasing function, what's a decreasing function.
So we forgot about that.
Oh, yes, increasing.
So, if I would ask you, listen, can you pay attention? If I would ask you a question from this graph, for what values of x is the graph increasing?
I'll tell you what, all of these increasing always. The process was not to
Alright. Listen, there are three intervals. When you say a graph is increasing, as x is increasing, y is also what? Increasing. When a graph is increasing, it means that as the x values are increasing, the y values are also increasing. So, throughout, these curves are increasing. But, because we have got asymptotes where y is undefined, here, when we write, we have got three intervals where the graph is actually what? Increasing. The first interval is going to be between 0 and 90 degrees. That's the first interval. Okay? The second interval is going to be between 90 and 270.
Oh, yes.
And the third interval is going to be between 270 and 360. So if a question is asking you to write down values of x such that the graph is increasing, for the time graph, you have to write three intervals. Okay? If the period is fixed, if the graph is given from 0 to what? To 360, you must have three intervals because of the existence of asymptotes. Remember, x is here, y is undefined. Y is undefined. Y is undefined. Therefore, the x value here is not included, or there's no value for what? For y. So x equal to 90 and x equal to 270 are not included in the solution. That's why we have got those three intervals. At x equal to 90, y is undefined. X equal to 270, y is undefined. Yeah, you can get a question like that.
Yeah.
Yes, you can.